Hi friends, today we will take the chapter number 13 of motion and that is named as motion and time, and this is the chapter number 13 of the science textbook class 7th. Welcome to EduMate e-learning another video. My name is Mrityunjay Khare and today we will discuss the chapter motion and time. So first I will be telling you that what is motion, then we will be concluding what is time. So, friends, as you know, in our day to day life, we can notice that there are countless objects in our surroundings. And out of these objects, some objects are in static position, or you can say in the rest position, and other objects are in motion. So, now the question is, what is motion? When an object changes its position with the time, we say that the said object is in motion. Basically, motion means changing position. So to understand the concept of motion, we can classify motion in three types, and these three types are straight or rectilinear motion. Second one is circular motion, and the third one is periodic motion. One more type of motion given in this chapter is rotational motion. So now we will be discussing about these motions in detail. So let us discuss. So here's the type of motion here, and we get the first motion, the type of motion as straight or rectilinear motion. So what is straight or rectilinear motion? When an object moves along a straight line path, it is called straight or rectilinear motion. And the example is motion of train on bridge. Thus, the second example is circular. The second type of motion is circular motion. When an object moves along a circular path, it is called circular motion. Example is motion of a merry-go-round. Third is periodic motion. When an object along a path and moves along a path and repeats itself after a regular interval of time, it is called periodic motion. Now the example is motion of simple pendulum or motion of a swing of periodic motion. So now the fourth motion, that is rotational motion. Now when an object spin around a fixed axis, it is called rotational motion. And the example is motion of blades of a fan or motion of earth on its axis. As you know, in the earth moves around, just goes is rotates around its axis. So it is an example of rotational motion. Now slow or fast. Friends, this chapter also discuss concepts about slow and fast motion. How to understand these concepts? It is very simple. When an object takes a long time to cover certain distances, is known as slow, and when an object takes shorter time to cover the same distance, is known as fast. Now, now the another way to just understand the concept of the slow or fast is called speed. The slow or fast concept is called speed. So we will discuss about speed. So now what is speed? In simple words, distance covered by an object in a unit of time is called speed of that object. So now here it is called, here in the slide, it is distance covered by an object in a unit of time is called speed of that object. And the formula is also given, so you can just note it down somewhere else. The formula to calculate speed of an object is speed equals to total distance covered divided by total time taken. This slash is this is the slash of the fractions of the in the mathematics. Don't take it as or. This is not or. This is fractional slash. Now the example of the speed is, the calculating speed is, If a bus travels a distance of 80 km in 2 hours, then the speed of the bus can be calculated as speed equals to 80 km divided by 2 hours, and that equals to 40 km per hour. So now we will be talking about here before this uniform and non-uniform motion in the screen. Here it is very important to remember that if we say that a car is moving with a speed of 50 kilometers per hour, it is clear that the car will cover the distance of 50 kilometers per hour in 50 kilometers in 1 hour. But one thing is very obvious, that the said car seldom moves with constant speed for 1 hour. Reality is that the car starts moving slowly and then picks up speed. When we say that the car has a speed of 450 km per hour, we usually consider only the total distance covered by the car in 1 hour. And we do not bother whether the car has moving with a constant speed or not in during the hour, if the car is moving with the constant speed or not. So speed which we calculate from an object is actually the average speed of the said object. It is not like the object will be just moving in that in the particular speed only. That's why we say that the speed of the total distance covered divided by the total time taken. So I think now I will be clear. It will be clear to you that what is speed. You can comment in the comment section below this video. I will your doubt. You can comment your doubt in the comment section if you have. I will just reply to you if you have any doubt. So now, no uniform and non-uniform motion we have. So what is uniform and non-uniform motion? It is very simple to understand. So first we will have uniform motion. When an object moves along a straight line with a constant speed, it is called it is said to be in uniform motion, or its motion is called uniform motion. And always remember, in uniform motion, average speed is the same as the actual speed. Non-uniform motion is when the speed of an object moving along a straight line keeps changing. So the motion will be called as non-uniform motion, or the object is to be in the non-uniform motion. So now it is crystal clear that we can determine the speed of a given object once we can measure the time taken by it to cover the certain distance. That means time is a major factor to calculate the speed. But big question is that how to measure time. So now, measurement of time. Today we will have a clock to measure time. But how the time was measured in ancient time? The ancient civilization like Harappa civilizations. I'm not talking about the civilizations. How the early man had a approximately, he told approximately that the time was this, and the second is and the hour is this, and the minute is this. Now we will study about some basic units in which the early man told the others that the time is this, and we will also be studying about some devices which were used before in ancient time. So in ancient time, people used to just used some natural events as unit to measure time, and such natural events which repeated regularly after fixed intervals such are given. For example, sun rises every day in the morning, so it was fixed that the morning is happening. So how was a day measured? A day was measured, so time by the time taken between sunrise and that the next was known between the one sunrise and the next was known as a day. From one sunrise to the next sunrise, it was a day. And similarly, a month was measured uh, from one full moon to the next full moon. As you know, the full moon is usually coming in 15 days. So the early man just used that full moon technique, so he could just measure it, the time, what is the time, or how is the month measured. And a year, the year was fixed as the time taken by the earth to complete one revolution of the sun. So many time measuring devices were used in different parts of the world before the I mean pendulum became popular. The pendulum clocks became popular. Sundials, water clocks, sand clocks, and are some examples of such devices. So, what are these devices? First, we will be studying about sundial. So, sundial is basically, a monument was fixed like in a straight part. As you also know that in Jantar Mantar in New Delhi, there is also a sundial that measures the day and night. So basically, the monument was used to measure the time, and it was also used for measure the time, and it was used, and it worked like the sun became if the sun is between is over the monument will show that it is straight 12 p.m. and so on from the shadow only. From its shadow, it will tell that what is the exact time. So basically, the sundial measures the time by position of the sun shadow casted by the sun. Now, sand clock. What is sand clock? Sand clock is not very familiar to you. Now, I will tell you what is sand clock. The device which uses the flow of sand from one glass tube to another in order to measure time is known as sand clock. If you have any doubt with the sand clock concept, you can just ask it out in the comment section. I will be just replying to you. Now, what is water clock, which I have told you earlier? Now, a device which uses the rate at which water drip from one vessel to another to measure time interval. It is known as water clock. Any doubts with the water clock concept? You can also do the same technique I have told you to fulfill your doubts. I mean, solve your doubts. In modern time, we often need to measure interval of time, which are much shorter than a day. Yes, the clocks or watches are perhaps the most common time measuring devices. You will also be having a clock in your house. That is not possible that you don't have any house. I mean any clock in the house, because this is the modern day, and the modern day says that the clock should be needed to measure the time and for understanding the what time is it. So wow, so the though the working of clocks are complex, but all the clocks make use of some periodic motions also. And one of the most common and well known periodic motion is that of the simple pendulum. As you can see on on the screen, you can see that there is written thread on the uh, on the on the pendulum's diagram, the first one, and that is the bob written there. And the second picture shows the mean position, that is O, and the A and B are the positions which the pendulum is going. So it is a periodic motion, an example of periodic motion. So now, what is this simple pendulum? A simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. Now, this metallic ball is called as bob of the pendulum. So now the periodic or oscillatory motion, which I was just revising and showing you that this is the example of periodic motion. But I have not tell you that the oscillatory motion and the periodic motion are the same. So the normally bob of the pendulum rests in its mean position. Its mean position, as you can see here, is O. O is the mean position on here. And when the bob of the pendulum is released after taking it slightly to one side, it begins to move to and fro. Here the fro is the short form of from. It will go to the other point and it will come back from where it had just released. This to and fro motion of a simple pendulum is an example of a periodic or oscillatory motion. So, oscillation. Now, what is oscillation? Pendulum is said to have completed one oscillation when its bob, starting from its mean position O, moves to A to B and back to O. Or you can say the pendulum's bob is released from A to B, A, and it goes to B and back and comes back to A. So, if you have any doubt with the oscillation concept, you can ask me in the comment section. And further doubts I will be clearing about this chapter only if you have any doubts. Now, time period. What is time period? The time period is the time taken by a pendulum to complete one oscillation. Now, the time period of a pendulum depends on its length, the length of the thread. Here, as you can see, the bob from the main position O goes to A and goes to B and will again come to O. But what if the B it comes from B and A, so and again B? Now this one oscillation between the time taken to complete one oscillation is called time period. The concept is very simple. Or you have any doubts, you can just do what I have told you. Just comment below and I will clear it in your replies. Okay. Now we understand how to measure distance and time. We can calculate the speed of an object. But there are devices also which are used. Now, speedometer is a device in which measures of speed of a vehicle as km slash h. It means that kilometer per hour. We can see speedometer in scooter, motorcycles, cars, and other vehicles. Okay. For now, for the formulas. The important formulas in this chapter are speed equals to total distance covered divided by total time taken. Distance covered is calculated by speed into time, and the time taken is equals to distance divided by speed. So now distance time graph. Now this is a concept of bar graph in the mathematics. You know that the graph paper is used to make graphs for data handling also. So basically now before I start this distance time graph, I will tell you the discovery of Galilei, which is which was a scientist of 15 from 1564 to 1642. Okay, so the invention of Galileo was this simple pendulum only. The famous scientist Galileo Galilei, which was born on 1564 and died on 1642, found that the pendulum is given at the length give that found that a pendulum of a given length takes always the same time to complete one oscillation. Now, what does that means? That means that the time period of a given pendulum is constant. This observation led to the development of the pendulum clocks, and the winding clocks and the wristwatches are refinements of the pendulum clocks. So basically, the simple pendulum and the pendulum clocks were the invention of Galileo Galilei. Now, I will be just telling you about the distance time graph. Now, distance time graph is a graphical representation of the distance covered by an object with its relative position with the time taken by the object. And the important types of graphs are bar graph, line graph, pie graph, or pie chart. Basically, in this chapter, we will learn about the line graph, but I am telling you about these graphs also, as you can get extra information about graphs. So now, how to make a graph now? So it is very simple. Making a graph is simple as you were learned in the mathematics chapter entitled as data handling, which I have told you as a bar graph. So a graph chart can be made very easily, like the bar graph in data handling in mathematics subject. Now what you have to do, take a sheet of graph paper and draw two lines perpendicular to each other on it equally, dividing the paper on halves, horizontally and vertically. Mark the horizontal line as XOX. I mean the end point of starting point of the line or the horizontal line as X. The point which is on which is it is mean just meeting the vertical line as O, and the end point of the horizontal line as XOX, and it is known as the x-axis. Similarly, make the mark the vertical line YOY, as I have told you, starting point Y, the point which is meeting by the horizontal line XOX by O, and the end point as Y. Now you will just be amazed to see that by y perpendicular, I mean by while you will just be drawing the lines, you will know that the O which is in XOX and YOY, the O is the same O which is repeated in XOX, and the XOXO is same as the repeated O in YOY. So now the YOY line is called as the y-axis, which is drawn vertically. Now you can remember these points by just rewinding my video to 10 seconds or 5 seconds. If you don't know the concept of these x axis and y axis, can't remember it. Now the point of intersection of XOX and YOY is known as the origin, and that is why I have marked it as O. Now the two quantities between which the graph is drawn are shown along these two axes. Now we show the positive values on the x-axis along OX. Sorry, the screen was just glitching. So similarly, positive value on y-axis are shown along OY. So now we will be just making a graph for the table given below, showing the distance traveled by a car and the time taken by it to cover that distance. Now this is the table 13.6, which is given in the NCERT chapter in the NCERT book and in the same chapter. Now this is the figure I was talking about in the how to make a graph. So YOY and XOX, you can see it. Okay, so now this is the graph for this motion of a car, which is marked as 1 minute 1 kilometer. It will be also giving on the further dotted lines which I have given, but it will not be I have not just marked it or done it, so you can just give it, just see that this is an example. So now so we will draw a bar graph like this, and the scale we will give time 1 minute equals 1 centimeter and distance equals to 1 kilometer equals 1 centimeter. And this is also an example of how making a bar graph, I mean the line graph. How to just make it by pointing by just meeting the making perpendicular lines on these points, as you can see. Now analysis of the aforesaid distance time graph. Now this is the distance time graph for the motion of the car. If here the distance time graph is a straight line, it indicates that the object is moving with a constant speed. If the speed of an object keeps changing, the graph can be of any other shape. Like here you can see a line is given in the distance time graph of the bus. I mean the bus is not that much important with whether the important is the line I've shown you here. So here are some points to be kept in mind while choosing the most suitable scale for drawing a bar graph or the line graph. So factors to be kept in mind while choosing a suitable scale. Now first point is the difference between the highest and the lowest value of each quantity. The intermediate of value of each quantity, so that the scale chosen is convenient to mark the values on the graph. To utilize maximum part of paper on which the graph is to be drawn. And these are the 3 points. So what is importance of distance time graph? So basically distance time graphs provides a variety of information about the motion of an object when compared to the data presented by a table. From the distance time graph, we can find that the distance moved by the object is at any instance of the time. So, friends, in last we will discuss about something about the units of distance and time. As per our requirement, the distance can be measured in different units as centimeter, inch, meter, and kilometer. Similarly, we can represent the time in different units, such as per second, per minute, per hour, etc. Now, to measure the time, there are uh, clues here which can measure. I mean, the destruction of the seconds are here, which can measure the time intervals, or you can say these seconds are joules. So the time intervals smaller than a second, which are the time intervals smaller than a second, as 1 millionth of even or as 1 millionth or even of 1 billionth of a second. These are known as microsecond and nanosecond respectively. So nanosecond, I mean macrosecond, microsecond is the 1 millionth of a second, and the nanosecond is the 1 billionth of a second. So friends, this is all about the motion and time. Thank you for watching this video. I hope this will be quite helpful to you. If so, please like this video, share this video, and don't forget to subscribe our channel EduMate e-learning, and don't forget to hit that bell. Bye bye and see you soon.